Hakim, I'm the Chief Researcher of the AI Research Center at TII. So we'll be discussing today, I think, an interesting topic around cybersecurity. Actually, it's the link between cybersecurity and LLMs and generative AI. I will go through 4 main points. The first one is just to set a little bit the background and why we are talking about this topic. The second one is more around the AI threat landscape. Then I will talk about few contributions that we are making in this field before I conclude. So why are we interested in this and why I am talking about this topic today? So it happens that TII is a large language model builder, among other things. So we build our own large language models for some time now, since 2023. And the latest release we had is back in May with the Falcon H1. That's a hybrid architecture combining transformers and state space models. The models that we build are pretty efficient and performing pretty well in terms of general knowledge, in terms of code, in terms of math, for example, and in terms of reasoning. We provide models with different sizes, going from 0.5B to 34 billion parameter models. And again, probably still I didn't answer to the question why we are talking about cybersecurity here. So the models that we are building support different capabilities and different tasks. I think this slide will be sort of working for most of the large language models that we have in the market. But I would say that these capabilities are actually basic capabilities of the models. So the green ones that you see in the screen are all the capabilities that we support. We do not support, for example, image generation. So we do image to text, but we don't do text to image, for example. But still, these capabilities, I believe, are pretty basic. So we started actually looking into the question on how to use or where to use these models to bring value to real problems instead of reproducing only things that are coming mainly from the natural language processing community. This is where we came to one of these problems, that is the cybersecurity. So within the cybersecurity, we focus on specific aspects that are the vulnerabilities and the malware detection in binary software. So I will be providing some inputs and highlights later on this. So cybersecurity and generative AI. So we have a group of people who are looking at generative AI as the ultimate solution to solve all the problems that are in cybersecurity. But we also look at the other group in the room, I would say, who's looking at generative AI as a big risk for the cybersecurity. And I believe both sides are right at some point, and we need to pay attention to all of them. The fact is that generative AI and AI in general is actually a blessing and is a curse at the same time. It's a double-edged sword, I would say. So it helps from one side empowering the defenders. Indeed, we can build solutions on top of generative AI that will be giving capabilities to defend against threats. And one of the interesting parts is that we can react in real time to these threats. But on the other hand, you have also the fact that this generative AI can be used to arm the attackers, and this is where the issue comes to the table. So attackers can create sophisticated malwares, and they can identify vulnerabilities on software and use them, exploit them before even getting identified by the providers of the software. So we have 2 teams here, I would say, the purple team and the attackers team, without calling it the red team in this case. So we can use AI actually to anticipate and neutralize vulnerabilities. That's an interesting point. And generative AI started actually showing some capabilities from this perspective. We can automatically identify or detect those vulnerabilities on software. Most of the work that is done currently is on source code, I would say, when it comes to software, but there are efforts as I will be showing later on the binary stuff. We have, I just mentioned here, 3 use cases. We have, of course, much more than that. So we have the first one, that is the threat hunting. So we can generate threat hypothesis based on what we have, actually what we see as patterns in the different softwares that we see. And then we have the second one, is the policy generation. We have a lot of regulation that is all around the place, a lot of documentation, a lot of recommendations that are coming from different bodies, from different regulation bodies. Following, keeping track of these recommendations and regulation is an extremely challenging aspect, and AI can definitely support into tracking these things, but also into generating recommendations for those bodies. And then we have the training aspects. We have a lot of platforms that are popping up to help people to get more exposed or more knowledgeable about the phishing, for example, that is doing more and more harm for the different companies. On the other side, we have the threat attackers, and these people, these groups, are actually trying to use generative AI for their benefits by creating new threats, I would say. The first one is actually the social aspect, where they are trying to infiltrate companies through different aspects by approaching or by using the social aspect. So there is the automated malware generation, and we see a lot of dynamic generation of this malware, which means that the speed at which the malwares are deployed is extremely high, making the defenders not capable of following what's going on when it comes to these things. 2 aspects. So you have the automated arsenal development. So just because we are having LLMs that are extremely sophisticated in code generation, code understanding, it became actually very easy to generate these malwares and to embed them, even with obfuscation, for example, capabilities. And then we have the social engineering, as I mentioned before. We have very sophisticated methods and very realistic methods that are coming more and more into the place through the digital life for people that are extremely difficult to identify at the end of the day. So we have these 2 words. We have AI for offense, where we are actually getting more sophisticated attacks at very high speed. And then on the other hand, we have the AI for defense. We are trying to help people to identify those threats extremely fast and eventually have some patching for those vulnerabilities, I would say. Some of the tools that are in the field for vulnerabilities and malware, at least. So we have the Copilot. I'm sure that everybody is familiar with this. It's using GPT or ChatGPT to identify different threats. We have the Google Cloud Security AI Workbench. We have the CrowdStrike Falcon. And we have the TII Bean Sloth that I will be discussing in the next slide. So just quickly giving you an overview of what we are doing in TII in this specific domain. So our strategy is going through 3 phases. The first phase is the analysis and the identification of the places where AI actually can bring value in this process of identifying vulnerabilities, identifying malwares, and down the road actually build automatically solutions using these generative AI models to support them. Then we have the second phase, where we augment the system, mainly by embedding agentic AI and large language models that are specialized in these vulnerabilities identification. And then the last phase is the automation and the orchestration of all this process to be able to at least support the agents that are working in this field. So what is Bean Sloth is actually a cyber reasoning system that is combining the capabilities of binary analysis, malware identification and detection, and then vulnerability discovery. So these are extremely important aspects, dimensions of all tools that are related to the security, and having a tool that is capable of identifying and patching these things are extremely important. So the key objectives of this platform, I would say. So what is this platform first? it's actually embarking two main things. I would say three, but two are the main ones. The first one is the model, so the large language model that is specialized, fine-tuned into the identification of the malwares and the vulnerabilities in the binary software. We do not work on the source code, but we work on the binary software. And then the second aspect is this multi-agent, I would say, dimension, where actually we make the system capable of interacting with different tools that are outside to be able to collect information, analyze them with the LLM, and then provide some outcomes. The third dimension that I was mentioning is more around the human expertise that we are collecting and embedding inside this ecosystem to be able to solve this problem. So the first stage that we are trying to solve here is actually helping the analysts to spend the time in what actually matters when it comes to the identification of these threats. So we speed up the process. We are not at the stage where we can automate all the process, everything, but at least we are supporting the analysts to be able to identify the things when it comes to a large stream of threats. So this is a quick comparison to similar tools, I would say, that are there. So most of the tools, actually, they fail when it comes to the binary analysis. They all work on source code. When it comes to binary, there is almost no tool that can do that, for example, plus all other properties that are there. Quickly, some of the results. So we started working on the fine-tuning of our 34 billion parameter model, the Falcon H1. And here we wanted just to show the difference between a base model and then a fine-tuned specialized model. We have done some work to make sure that the model that is used for this kind of situation is actually doing better when it comes to vulnerabilities. And you can see it's a little bit small, but you have different aspects related to vulnerability identification where we fine-tuned the model and we were capable actually to perform much better than the base model. Evaluating these models in this context is not an easy task. We don't have a lot of benchmarks, so we took the public ones that are there to verify if we are doing a little bit good, I would say. So these are some results that we have there. So the model is capable actually to identify, to have a success rate of almost 82% when it comes to vulnerabilities from the binary code. The second thing is related to the malware identification. Again, we took some public benchmarks that are there to be able to assess and evaluate the model. We reach accuracy that is around 92%. We still have a lot of evaluation to do. We are exposing the platform to also users, experts, to see the feedback that we can get from those experts to see if we are at least on the right track. I have a quick video that I just want to share with you.
At the Technology Innovation Institute, we push cyber defense forward because in this domain, every millisecond counts. BinSleuth, TII's next-generation cyber reasoning platform, powered by Falcon, the flagship LLM built by TII, is engineered to analyze binaries with unprecedented depth and accuracy. It fuses static and dynamic analysis, enhanced by advanced program comprehension, to uncover hidden behaviors, vulnerabilities, and malicious intent. It detects high-impact memory corruption vulnerabilities, such as buffer overflows, heap overflows, and use-after-free conditions, long before attackers can exploit them. BinSleuth delivers faster, smarter, and more actionable intelligence at scale, empowering experts to stay ahead of evolving threats. And it does the heavy lifting. BinSleuth processes large-scale binary streams automatically, so analysts can focus on what truly matters, understanding security issues and responding with precision. With fuzzing-enhanced vulnerability detection, malware, and AI-assisted capability and backdoor analysis, BinSleuth delivers expert-level insight at every stage. BinSleuth by TII. Expose threats, eliminate risk.
So the demonstration is available there for those who want to go and check it out. But again, the point here is this sort of combination of generative AI with cybersecurity. We always complain about what are we using AI or generative AI, in which domains are we using this AI, where can we use it to add value. We believe that one of the domains will be the cybersecurity, and the value will be extremely, extremely high. Just for the future in this domain, probably, so quickly, the autonomous defense systems will become more and more autonomous if we are capable to generate enough data to teach these systems. There is the predictive intelligence, being able to predict issues before they come. The vulnerabilities, for example, supporting software engineers with these kind of platforms will allow to build a much proper code. And then you have the hyper-personalized security, a security that is capable of adapting to the behavior of the user, depending on the context and the level of expertise. And then you have the AI versus the AI conflicts. There will be a lot of work, that will be a lot of issues that will be generated with AI, but probably we'll have a lot of solutions that will also come from AI. Thank you very much for listening. You have the model that is there. Please feel free to test it. Thank you.